exponential functions. That's it. You know that you already got various type of function. Polynomials is just combination of the powers of the x. Okay, that's a polynomial function. Radical function is where we get the variables inside the radical. In this case, you are going to have exponential function. This is where the variable is going to be exponent of the something. So this is a review from algebra, as much as we need. Okay, just we recall that the definition of these functions. Just do it quickly. If you have any question, let me know, then I can explain it more for you. Recall that if b is a positive number, if b is a positive number, okay, positive number with one condition, with the condition that the b is not equal to 1. Okay, if this is going to be the case, then an exponential function, okay, exponential function with base or at base, okay, with base b is going to be defined by f of x equal to b to the x for all values of x. Okay, so it's going to be a fixed number, then you raise it to the, okay, raise it to the x. The variable is going to be, would be up there. Okay, the base, of course, cannot be equal to 1 because 1 to the x would be 1. You just get a, okay, you are going to have just a constant function. And we are not going to use the negative base. Okay, so this is going to be the exponential function at base b. So, for example, this is going to be the case. You see f of x equal to the 2 to the x. 2 to the x is going to be an exponential function. Okay, exponential function with b equal to the 2, base equal to 2. Okay, so this is going to be the case. Now, you should be able to find the domain of this function. You see this x can be any real number. Just remind you that, note that from algebra, we can find any exponent if you like. You see, look at this one. Note that if you want to find, for example, 2 cubed, it's going to be what? 2 cubed is going to be 2 times 2 times 2. It's going to be 8. So we can have a positive number. So if you want to find the 2 to the negative 4, you know that we can flip it and write it down as 1 over 2 to the 4th. So 2 to the 4th would be 16, so that gives 1 over 16. Okay, so I can do the positive number and the negative number. Okay, so what else? So what is going to be 4 to the 1/2? So 4 to the 1/2, you know that's going to be radical 4. So the radical 4 would be 2. So I can have a positive fraction or rational number. Okay, if you want to find a to the negative 1/3, you know that we flip it, it's going to be 1 over 8 to the 1/3, which is going to be 1 over cube root of 8. Cube root of 8 is 2, so that gives 1/2. So I can have a positive integer as a power, negative integer. I can have a positive rational number. I can have a, okay, negative power. So everything would be fine. So except this last one maybe. What is 3 to the radical 2? Any suggestion? What's 3 to the radical 2? Any suggestion how we can find it? We cannot find it because the radical 2 is going to be a rational number. So what we're going to do, we estimate it. We estimate it by using the calculator. Okay, you know that the 3 to the radical 2, you know, we can use your calculator. This is going to be 3, and you are going to use the, okay, where is the power? Okay, the power notation. What is the, this is my new calculator. Where can I see the power on this one? There's a notion of the power. Okay, that's my old one. Get the old one, but this is going to be, you see the way we do it, we approximate it. We approximate it, it's going to be almost like 3 to the radical 2 is going to be something like 1.4 if you like. You get the 1.4, then you can, you know, you can raise it 3 to the radical, okay, 1.4, and that give you an estimate. You know, I just check it with the other calculator for you in a minute. Okay, so the problem is going to be, as you can see, I can use any power you like. So this means this function that we're going to use, b to the x, the domain of this function is going to be all real number. So therefore, that's very important for us, that if f of x is going to be equal to the b to the x, okay, it can be defined for all values of x. Values of x, and the domain of this function is going to be all real numbers. So that's why we like this. We like this function to use it, you know, all the time. So I'm going to put some property of this function together. Okay, the way we like it for calculus, to get these numbers. Okay, so what is going to be properties that we need? Properties of this function, y equal to the b to the x. Now, the first one, which is going to be important for calculus, is the domain. So as we talk about it, I can use any power. Even if I need it, I can use my calculator. So the domain of this function would be all real numbers, negative infinity and positive infinity. That's going to be the domain. Okay, the range of this function, okay, the range is the output. You see, the output, since b is a positive number, so the output is always a positive number. So the range of this function, okay, the range would be 0 and positive infinity. So this exponential part is never negative. Okay, what you want? You're done. Okay, I do that. So this is going to be the case. So the domain of the function, okay, this is it. The domain of the function is going to be all real numbers for the exponential function, but the range is going to be all positive numbers because b is a positive number. So in particular, this b to the x is never 0. Okay, this is one property. The other property is that you see, you know that b to the 0 is equal to the 1. And the other definition of the property of the exponent, if you have the b to the x1 times b to the x2, the result would be b to the x1 plus x2. Okay, if you multiply with the same base, you add the exponent. And if you divide b to the x1 divided by b to the x2, this is going to be b to the x1 minus x2. Okay, if you divide, you subtract the exponent. If you multiply, you add. And the last one is that if you have an old exponent, b to the x1, and you multiply by the new one, so that gives you b to the x1 times x2. Some of them are going to be used, so that's why we just want to make sure you remember it. Any question? So these are the usual idea from algebra, okay? And there is another property, we call it one-to-one property. We are going to use it in order to solve the equations. And that's the case that if b to the x1 is equal to the b to the x2, then x1 is equal to the x2. Okay, in algebra, we call this one-to-one property to get these type of numbers. Okay, any question? These are all algebra. Now, what's calculus? In calculus, we are interested in what? Interested in continuity, interested, in the getting the derivative of this function. Okay, so these are going to be the one. Any question? I want to go to the next page. So this is going to be the case. So what do you want? I don't know. This is it. So if you want that, the very top, that's the very top. I can come back and show you at the end of the lecture if you want, if you missed anything. Okay, so so these are going to be the preliminaries. But what we are going to be interested in the shape of these type of graphs. Okay, so we continue. So that was a number 3. This is going to be number 4. Okay, for the number 4, this is going to be the case if the base, if b is going to be bigger than 1. If the b is going to be bigger than 1, then the function y equal to the b to the x is going to be increasing. Okay, increasing. And if the base is going to be between 0 and 1, then the function y, okay, this is it, y equal to the b of b to the x is going to be decreasing. Okay, and these are going to be the graph of this function. You can collect some points to graph it. You say this is going to be the one. If x is equal to the 0, the function is going to be 1. So if it's going to be increasing, you see the domain is negative infinity and positive infinity. So what you're going to do, you're going to start from here. It's going to be up, 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 up. So this is going to be the graph of y equal to the b to the x when b is bigger than 1. If b is going to be less than 1, it's going to be the other way around. E is going to be decreasing. Okay, these are going to be decreasing. So this is going to be b to the x when b is going to be less than 1. If the actual one is given to you, you can collect some points and you put them together, but you don't need really those type of idea in full details. But this is going to be the shape of this function. You see the red one is b bigger than 1. It's going to be up, 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 up. And the other one is going to be down, 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 down. So that's going to be increasing and the decreasing function. Okay. So if you want to, we can stay with this base all the time. But there is going to be a special base that we're going to be interested in calculus. Okay. So that base would create a special function that we call it natural exponential function. So I quickly to go to the natural exponential function and we continue from there. Okay, so what is going to be the natural? Your main job is section 4.3. What is going to be the natural exponential function? Natural exponential function. For the natural exponential function, because of the application in science, there is going to be a very special base that we're going to use. So that base would be the following. The natural exponential function, the natural exponential function. Okay, exponential function is going to be denoted by, the function is going to be y equal to the e to the x. That's it. E to the x, again for all values of x, where this e is going to be a number like the pi. It's going to be not something like 2.731, etc. Of course, it's going to be an irrational number, okay, like the pi. Pi is not 3.14. So e is going to be the same thing over there, okay? So this base, okay, this base is going to be very much consistent with whatever we like to do. Especially, we are going to be interested in the rate of change, and this base is going to be more popular than the other ones. Okay, different way to describe it in your book, but we want to get to the property of this function quickly. Okay, so the natural exponential function is denoted by y equal to the e to the x, but e is going to be a irrational number. If you want to work with this function, you should be able to use your calculator all the time, and we need it. Okay, so if it's going to be your calculator, so what you are going to do is you are going to consider the ln function over here. Okay, this, if you have a brief one, it would be better, but you have it's going to be the different operation that you have. You click on the second and you get e to the x on the usual calculator that you have. So you should be able to, to evaluate it, work with it, and we are going to give you various examples. So this is going to be the format of this function. This function is going to be increasing function because the base is, the base is e bigger than 1. So roughly this is going to be the graph of the, y equal to the e to the x. Okay. Now, why we are going to be interested in this function? Remember, we are interested in the rate of change. So this is going to be the only function that its derivative is the same as the function. The derivative is going to be the same as the function. And from that, the rate of point change of point of view is going to be important for us. So we give you quickly this theorem to get the derivative of this function. That's your main job. Okay. Now, the function, the natural exponential function, is differentiable. Okay, y equal to the e to the x is differentiable. And its derivative of e to the x is the same as e to the x. There is only one more function with this property. That function is zero function. But if you want to consider a non-zero function whose derivative is the same as the function, is just e to the x. That's why it was introduced by Euler. We use this one in general. Of course, you may have something other than e to the x. So in general, if u is equal to the u of x, is going to be what? Is going to be a differentiable function. If this is going to be a differentiable function, then we are going to use the chain rule. Then you see what's the derivative of e to the u. You see now it's a composition of two functions. E function, u function. Remember the chain rule? The chain rule was what? Like u to the n that we have. Is going to be equal to the derivative of the e function. Derivative of the e function is the e function. It's just e to the u. But remember the chain rule? You have to multiply by the derivative of the u function, which is u prime. Okay, so if it's going to be e to the x, the derivative of e to the x is just e to the x. But anything else means even e to the negative x, e to the 2x, e to the x squared. So you repeat the e function as is, but you have to pay for it, u prime. That is the most popular formula in calculus. And you will see many, many applications of this one. Okay, any question? Let's get practice. How we're going to find the derivative of the function using this exponential function. Okay, so the rest is just the algebra. Most of the operation that you are going to use, those algebraic part can be used by a calculator. So you have to focus on the derivative of the function and its application that we're going to have. And we are going to have quite a lot to talk about it. Okay, question? So let's see what is the question that you should answer for us. First, finding the derivative for us. You will see this type of question directly on your next test and of course on the final. That's it. Find the derivative of each function. Find the derivative of each function. Each function. These are all in 4.3. 4.1 and 2, you can read it for yourself. But 4.3 is the one that we are going to be interested in. Now, the type that you see, the first one. The first one, we call it ordinary one. So look at this one. F of x equal to x cubed, okay, minus, let's say 5x squared plus 7e to the x minus 12. You want to differentiate it. You differentiate it as you did it before. But remember, derivative of e to the x is just e to the x. Okay? So what's going to be the solution? Solution is going to be f prime of x is equal to derivative of the x cubed is simply 3x squared. This one 2 times 5, 10 minus 10x. You see this is plus 7 times e to the x. So it's going to be plus 7 times the derivative of e to the x. Derivative of e to the x is just e to the x. And derivative of 12 is 0 and you're done. Any question? So remember, derivative of e to the x never change. It's e to the x and it's done. That's a type 1. No chain rule is needed. Okay. What is going to be the second one? So this is the first one. Now the second one. Very popular one, the second one. F of x equal to 3x to the 4th times e to the x. You see, this is a product of two functions. So you have to apply the product rule. Remember the product rule, just remind you. See, this is the first function, and this is the second function. Remember the formula? Just remind you the product rule. Derivative of the first times second plus derivative of the second times first. Now apply the rules. F prime of x equal to derivative of the first function, power 4 times 3, 12, 12x squared. Sorry, 12x to the 3rd times the second function, e to the x, plus derivative of a second function times the first one. What's the derivative of a second function? Derivative of the e function is just the e function. So times the first one, 3x to the 4th, e to the x, and you're done. Okay, we just apply the product rule. Derivative of the first times second, 12x cubed. Times the second is going to be e to the x plus derivative of the second times the first one. The second one is just the e function. Derivative of the e function is going to be the e function, and you're done. Okay, any question? Now, there were no chain rule here. Now, the tricky one is this one. Bringing the chain rule. So, look at this one. g of x equal to e to the negative x squared. If you've done a statistic, you should be familiar with this function. This function in the statistics is called normal distribution. And the graph of this function is going to be roughly like this. Okay, this is going to be the graph of this function. They like it in statistics because this area under this curve, you are going to modify it, of course, is going to be like 100%, or it's equal to the 1. They like it in statistics because you know that the probability, the total probability that you can have is 100%. So they use this one quite a lot in in a statistic. In calculus we do the job, but they just use a table over there. That's why this is a popular function. Okay, now we want to differentiate it. To differentiate it, this is not e to the x, it's e to the u. So you have to use the chain rule formula. Okay, so what's going to be your formula? So this is going to be like e to the u. Okay, just remind you solution. You see, g prime of x is equal to derivative of the e function is the e function, e to the negative x squared. But it's not e to the x, it's e to the negative x squared. So you have to multiply by u prime. U prime derivative of the top, negative 2x. We usually flip it, switch it. We write negative 2x e to the negative x squared. Okay, so I just use this formula. Derivative of e to the u is e to the u times u prime. Okay, so if it's going to be just e to the x, derivative is just going to be e to the x. But if it's going to be e to the something else, you have to pay for it, u prime. Any question? So that would be the type 1. Now, if we combine them together, we get this one. This is going to be used quite a lot because there are a couple of applications in business or social science using this function. So we are going to meet this function several times. So let's get to know it. F of x equal to, it's going to be something like, let's have 100x times e to the, it's going to be something like negative 0.02x. You see? Why we are going to be interested in this function? Because it's going to be kind of revenue function. Remember, your revenue function is x times p. So in this case, it's going to be the format that you have. Your price demand equation is going to be exponential parts. So that's why you see it from time to time, in different places in this book. And we are going to work with it again, okay, later on. So the first thing to do if you want to work with this function, you have to differentiate it. Now to differentiate it, this is going to be the product of two functions, you see. That's product of two functions. So the first function is f, the 100x. The second function is going to be exponential one. So you know that you have to apply the product rule. Just remind ourselves that this is going to be what? It's going to be f prime of s plus s prime of f, if you like, okay? It's going to be the derivative of the first times second and the second first. Now, derivative of the first one is easy, 100x. This will be 100 times the second one. But derivative of a second times first, that's a crucial one. The second one is the e function, but it's e to the u. So for the second part, you have to use this formula. You see the derivative of e to the u is going to be what? Is e to the u. But remember, you have to pay for it, u prime. So these are the formulas that you need to be able to take care of this function. Okay, are you ready? Now let's differentiate it. So f prime of x equal to derivative of the first times second. Derivative of the first one is 100x will be 100 times the second function. Second function is going to be e to the negative 0.02x. That's the derivative of the first times second, plus derivative of the second times first. What is the second one? E function. That's e to the u. E function never changes. The derivative would be e function, e to the negative 0.02x. But you have to pay for it, u prime. U prime is derivative of the top one. Derivative of negative 0.02x would be what? Would be negative 0.02. Okay? Derivative of e to the u times u prime. So what is u prime? Negative 0.02. But you have to multiply by the first. Multiply by the first means you multiply by 100x. Any question? So derivative of the first times second, 100, plus derivative of a second times first. Second is what? Second is the exponential function. So derivative of exponential function is exponential function. But what's the power? Is it x? No, it's not. Negative 0.02x. So we have to multiply by u prime. But times it by first. You're not done. Some people just leave it as is. No, you can't do that. You have to simplify this part. Remember monomials that we talked about it before? So you have to multiply these monomials together. So what we have, it's 100 times 0.02 would be 2. It's going to be 200, but we have 2 decimal places here. So it's going to be negative 2x. You see, this is going to be negative 2x. But we put it up in front. So the function is going to be f prime of x is equal to what? Is equal to the 100 e to the negative 0.02x, okay, minus 2x e to the negative 0.02x. This is going to be the derivative of your function. Any question? Get used to work with this function. I'm going to show you in a minute that why we are very much interested in this function to get the derivative of this function. Okay, any question? So we have a new tool. So what are we going to do with this tool? Okay, we have what we did previously, what you did today, if you like. So if the function is given to you, we may be interested in finding the maximum and the minimum of these functions. Okay, especially with the exponential function. It may be a revenue function. If it's going to be a revenue function, we ask for the maximum revenue. So I'm going to find the maximum revenue. Okay, so I'm going to give you one of those type of problems. Okay, in your book they are you got a very mild one, but I'm going to give you something similar to this, and then we are going to use it in future again. Okay, any question? Pay attention of this one. And there are some technical points to checking this type of function. Okay, so this is your second question on the exponential function. Then we can go, and we have a natural log. We try to do it on Thursday, and we finish these 2 sections quickly because we have quite a lot to do in the chapter 5 and 6. Okay, so this example again is very fundamental to our argument, the method, the way we are going to apply it. It's going to be interesting. So what's the question? The question is, would like you to find, okay, find the, let's say, relative or absolute. It's going to be absolute, but we call it relative. Relative extrema, maximum or a minimum of the function, okay, of the function, okay. Let's have this function. So f of x is going to be equal to, okay, so let's go with the f of x. Let's start with this one. Is going to be your x squared e to the, okay, x squared e to the maybe negative 2x would be fine. It's going to be decimal number, but I just want you to check this one first. Okay, relative extremum, like the function that you did tonight, but this is going to be a new one. Okay, there you are. Domain first. What's the domain of this function? You see the x squared is a polynomial. It's exponential function. Remember, the exponential function is defined everywhere. You can use any x you like. You look at the top only. Negative 2x is a polynomial because the rest is calculator. Okay, so no restriction on this domain. So the domain of this function is nicely negative infinity and positive infinity. On the test, some of you missed the domain for the question. I graded up to the 5 questions, especially number 5. Number 5, they asked for the 4 and 5. They asked for the critical values. Okay, so you need the domain first, remember. Yes, okay, especially 5b, you need that domain. So the domain is going to be all real numbers. You know what to do. You want to find the relative extremum, you have to find the derivative of the function and let it equal to this derivative, f prime. For the f prime, again, it's a product of two functions. The first function is x squared. The second function is the e function. So derivative of the first easy, derivative of x squared, 2x. Times the second one, e to the negative 2x. Done. That's the derivative of the first times second, plus derivative of the second one. What's the second one? E function. The derivative of the e function is the e function, e to the negative 2x. But it's e to the negative 2x, so we have to pay for it. U prime. Derivative of the top, which is a negative 2. Okay, if it's going to be e to the x, u prime would be 1. That's why derivative of e to the x would be e to the x. But it's going to be anything else, you have to pay for it, u prime. Okay, but this is derivative of the second one, times it by the first one, times it by x squared. Okay, we have to simplify these monomials, put it up in front. So what we have the f prime of x equal to 2x e to the negative 2x minus 2x squared e to the negative 2x. You see, this is going to be the nature of this function, f prime of x. Now you want to let it equal to 0. Now there is one property of this function that's going to be very useful for you. What is that? Because of the exponential function, you see, because the derivative of the exponential function is the same, there is always a possibility to pull out this exponential function as a factor. It is always possible. So as soon as you differentiate it, pull out that common factor out. There are some other common factor. You can do that one too, but this must be done quickly. Okay, it's always possible. That will help you quite a lot for the rest of the problem. Okay, so what I'm going to do is I'm going to pull it out. You see, when you pull it out, the rest leftover is going to be so easy to handle. 2x minus 2x squared. Okay, I could have, factor of the 2x too, but intentionally I didn't do that. Any question? It's always possible. Pull it out. So this is going to be your f prime for the rest of the problem. What next? You have to let it equal to 0, remember, to find the critical number. So let's do it. What's going to be f prime of x equal to the 0? F prime of x equal to the 0. So this means this must be 0. E to the negative 2x times 2x minus 2x squared equal to the 0. Now you see a product is 0. You know that when a product is 0, each factor must be 0. So this factor must be 0. E to the negative 2x equal to the 0. Never. Why? Because remember the E is 2.7. Okay, E is 2.7. It doesn't matter whatever you do on the top. You never be able to make it E to 0. That's why I factor it out. Okay, I factor it out. Now I know that it's not going to be 0. So the second one must be 0. 2x minus 2x squared equal to the 0. Any question? So you have to pull out this one out here. So when you let it equal to the 0, you get rid of this one quickly. It's like dividing, drop it. Why? Because this one of them must be 0. The first one equal to 0, never. It's a contradiction. So we have only the second one equal to the 0. Second one is ordinary equation. You can use factoring to solve it. Okay, so the common factor here is 2x. We pull out the 2x. Okay, what's going to be the leftover? The leftover is going to be 1 minus x equal to 0. Okay, now 2x equal to the 0. So that gives one solution, x would be 0. So x equal to the 0 is going to be one solution. Okay, 1 minus x equal to the 0. 1 minus x equal to the 0. That give you what? That give you x equal to 1. So you are going to have what? You are going to have two critical numbers. The critical numbers are going to be 0 and 1 over here. Okay, any question? So this is the way we are going to operate from now on. So the key was just taking that exponential part out. Okay, just checking to see if I can see my notes. No, not yet. Okay. So what's going to be the next step? As usual, you know that you drop back these into the function, and then you are going to test it. So let's go back to the function, find f of 0. So that's going to be the next step. You have to follow all the steps that you did for ordinary function. So we are going to find f of 0. And this is your function. You see this is your function. If you put a 0 here, so you get 0. Okay, it's going to be, I write it down for you. It's going to be 0 times e to the 0. This is going to be 0. So f of 0 is equal to the 0. Okay. Then you have to find f of 1. What is going to be f of 1? Again, you put x equal to 1. If you put x equal to 1, that give you what? That give you 1. Okay, it's going to be 1 square if you like, e to the negative 2. So it's going to be just e to the negative 2. E to the negative 2 would be 1 over e squared. You can use your calculator and find it as I talk about it, or just leave it, okay, leave it as is. We accept both of them. If it's going to be, problem about dollars, miles, gallons, then we find it. But for this problem, we don't need it. So that gives 1 over e squared. Any question? So these are going to be your critical values, okay? So now testing. You have to decide how we're going to test it. Testing. So look at your f prime. You see, look at the f prime. This is your f prime, or this is your f prime. You have two choices: first derivative test or second derivative test. You just look at your f prime to see which one are going to use. You see, this is going to be f prime, and this is going to be e to the negative 2x times it by what? 2x minus 2x squared. Okay, which test is easier, you think? The first or the second? Or which one do you prefer?
The second.
The second. Let's see if you're right. It can be done. You see, for the second one, you have to use the product rule here. Derivative of the first times second, second first, or originally one is the same thing. Some people, they do it. You see? It takes times because you know that when you do it, then you have to substitute the 0 and 1. No. My suggestion is the first for this one. I mean, it's not correct. It's not wrong. You can do it if you like. But I prefer the first. Remember what's the first? For the first one, you need a chart. So I go with the first derivative test. First derivative test, and I'm going to tell you why. You see, the reason is, this is the first derivative test. You need a chart. Remember, you need the x. you need the f prime, and this is going to be your function, f of x. So the domain of your function is negative infinity to positive infinity. You're checking two numbers, 0 and 1, 0, 1. Where did you get it? You let f prime equal to the 0 to get it. What is your f of 0? F of 0 is 0. What is your f of 1? Is 1 over e squared. You see, you have to determine the sign of the f prime. Remember, increasing, decreasing. 1, 2, 3. This in the middle one, from 0 you go to the 1 over e squared. This is going to be what? This is an increase. So this is positive. So you need only check two numbers here. Look at this one. You see the situation they're going to have. This part over here, you see the exponential part. This exponential part is always positive. We already talked about it. Why? Because e is 2.7. So you have to check only the sign of 2x minus 2x squared. Okay, what is 2x minus 2x squared? Is a quadratic function. Remember, when it's quadratic with two solutions, between the solution, opposite sign of the x squared, positive, outside, same sign, negative, negative. You see, quickly we get it. Don't like it? Test the numbers. You see 2x minus 2x squared. Between negative infinity and 0, you test one number. You test negative 1, if you don't like this method, of course. If you don't like this method, so what you do is you are going to test a number. You see, you test a negative 1 here. But you just test it in 2x minus 2x squared. You see, 2x minus 2x squared. If you substitute the negative 1, what are you going to get? You get the 2 times negative 1 minus 2 times negative 1 is squared. So that gives you a negative 2 minus 2, that gives you a negative 4. It's a negative number. So that would be negative. Between 1 and positive infinity, you can pick a number like 2, for example. You don't need it, but you can check that. If you check the 2, that gives you 2x minus 2x squared. You replace the x by 2, so that gives you 2 times 2 minus 2 times 2 squared. So it's going to be 4 minus 8, which is a negative 4. It's negative. You see, you don't need to bother about the exponential part because it's always a positive number. So you have two options, checking the numbers. So this is f prime negative, means you're going down and you're going down. That's it. So at this point, we get the minimum. At this point, we get a maximum. F of 0 equal to the 0 is a relative minimum. F of 1 equal to the 1 over e squared is going to be a relative maximum. And you have all the information that you need for this function. Okay, so if you don't like this method, you can use the second derivative test, but it can be done, but it's going to be messy because you have to find the derivative and you substitute x equal to 0. So I suggest the first derivative test for this one because this exponential factor is always possible. This problem that I gave you is a kind of a two-match one because the one that you have is this is not x squared, it's just x. So when you get to this part, you are not going to have even a quadratic one. You get something like, x minus 2, x plus 2, then quickly you can check the numbers and get it. But decide which one do you want to do because you have to deal with this one. This is going to be your main problems. And you will see it in your next quiz, and even you may see it on the final. This is a kind of optimization problems for the exponential function. And that's it. We give you a couple of more examples, but otherwise we are done with the exponential part. We don't need anything else to know for the time being. So quickly we go to the natural log function. Okay, so check 4.3. We may assume, I think we may assign the 4.1 and 4.2, but that's going to be for your information. We need the 4.3. You have some nice question regarding the differentiability, and these just the examples that I did are all that you need for the time being. Okay, that's it. Any question?
Could you explain one more time why you would know the outsides are both negative with just looking at 2x minus 2x squared?
You see, remember we already talked about it. This is a quadratic expressions. You see, negative 2x squared plus 2x. If you had quadratic expressions or equations with two solutions, you see you have two zeros here. Between the zeros, the sign is opposite sign of the x squared. Sign of the x squared is negative, so the opposite sign would be positive. Outside is the same sign, negative and negative.
Okay.
See, this property is nice to know for the quadratic, quadratic expression. So if it's quadratic with two solutions, in between the sign is the sign of the x squared. It's negative. Opposite, sorry. Is the negative, the opposite would be positive. Outside, negative, negative. Otherwise, you have to check the numbers. Okay, but it's nice to know. But the actual one that we have, it's going to be a decimal format because we're using rate 2%, 3%, 5%. So this number is not going to be a square, but it's nice to know the squares. Okay, to get. I'll give you one more. Okay, on Thursday. One more examples, the one that we use in application problems. And then we take the natural log quickly, a couple of, okay, refreshing your memory, but there is a derivative of that one that we are interested in. And we finish this chapter by the end of this week so that we'll be able to get to the, okay, to the main part of the course, chapter 5. Okay, that's it. Have a good one. Check these examples. Get your